Hello everyone, welcome to LFI Educates. Children, today we are going to discuss about acceleration. Acceleration is the rate of change in velocity, or we can say that the change in velocity with respect to time. It is defined as change in velocity per unit time. And if you don't want to write per unit time, you can write even like this. It is defined as rate of change in velocity. Acceleration, mathematically, we write it as A. It is change in velocity per unit time or time interval. Now here, if you see mathematically, it is change in velocity with respect to time according to the definition. What does acceleration exactly mean? Acceleration is the increase in velocity after every interval of time. Suppose say in one first second the velocity of the body is 10 meter per second, then the next second it became 20 meter per second, next second it became 30 meter per second, like it constantly increasing the velocity, or it can be constantly decreasing. Suppose you are moving in a vehicle, then in the beginning you will start to accelerate, the velocity will try to increase. That is positive acceleration. We will come to know about positive, negative and zero acceleration now. Or suppose after attaining the maximum speed, suppose say 30 km or 50 km per hour you are driving the vehicle, then you want to stop, then you have to retard it. Retardation, negative acceleration you have to apply. Negative acceleration indicates the decreasing the velocity from 50, then it will come to 45, then 40, then 35, then 30, like it will come to 0. The decreasing the velocity is also known as acceleration. Now if I take the change in velocity as these two, I'll take it. Final velocity, generally it is written as V, and initial velocity we write it as U. So if I take these two velocities, final and initial, then I will be writing here V minus U divided by T. That is the change in velocity, final velocity minus initial velocity with respect to time in the given time interval. Now here, if V is bigger than U, that means final velocity is more than initial velocity, then acceleration is positive. Positive acceleration, you will get it. And if the final velocity is less than initial velocity, then the value of A will become negative. If V is less, U is more, like 3 minus 5, it will be minus 2. Then the answer will come out as negative. Then acceleration is called negative acceleration. That means the driver is decreasing the velocity with respect to time. And sometimes acceleration can even be 0. If V and U both are equal, then there will be no acceleration. Acceleration will become equal to 0, neither positive nor negative. And this negative acceleration, sometimes we call it as deceleration, or we call it as retardation also, or retardation. Retardation or deceleration, when we use the term, then it indicates negative acceleration. Acceleration is negative. So this is all about your acceleration. Now let us see about average acceleration. Average acceleration over a given time interval is defined as the change in velocity over or change in velocity per unit time interval or time interval. This somewhat means the same as that we have discussed about acceleration. This is generally used when we treat graphically like this. In a velocity time graph, suppose x-axis represents time and y-axis represents the velocity. Suppose a graph is given to you. Suppose this is the case. As time passes by, the velocity keeps on changing. Sometimes it becomes more, sometimes it becomes less. So like it, I got one curve, suppose this is given to you. They may ask you, or we may be interested in to know what is the average acceleration of the object. Here they are showing in the graph. Now what you have to do is you take 2 points on the graph like this, A, B we write, like these 2 points we are taking. You come towards your y-axis. Here this will be your final velocity. Let me mark it as V2. And initial velocity, let me mark it as V1 here. Then you come down towards time also, time axis also, perpendicularly. Then here suppose initial time T1 I will mark, and here final time T2. Then if you extend this line and from 90-degree angle here, let me mark it as C, this right angle triangle. From here, if you take the slope of this curve AB, slope, we write it as tan theta. Tan theta is equal to perpendicular by base. Perpendicular is BC and base is AC. BC, this length will be B to this point minus C to this point. That will be BC will be V2 minus V1. If I write this point as D here, it will be BD minus CD. BD minus CD. And AC, if you say AC, if I mark this point as E, then it will be OD minus OE. OD minus OE. Now BD, as you can see in the graph, BD is equal to V2, V2 minus CD. CD, you can see it is V1 divided by OD. OD is T2 and OE is T1. T2 minus T1. Like this you can find out the average acceleration in graphs. This one we call it as slope. The slope indicates what is this angle, this one you imagine as straight line. This angle we are going to find out. Theta will give you the slope. So regarding slope, if I say now, you have to know it very clearly. What is slope? So let us discuss first what is slope. Then after that again we'll come back to average acceleration. One numerical we'll do and see. Slope of a line and in this this slope is giving you what? Velocity divided by time. Change in velocity with respect to change in time gives you the acceleration. It is giving you the acceleration here because y-axis, this side is velocity and x-axis is time. This velocity divided by time will give you acceleration. So you can even learn one thing here. The velocity time graph, if you draw, then if you find out the slope of the line of the curve, then we get acceleration. We will get acceleration. So slope of a velocity time graph gives us acceleration. This is the meaning of the term slope. Suppose you have got two curves I am showing you here. One graph, this is x-axis, y-axis, this is x-axis, y-axis, this is the origin. One graph you have got a line like this. OA is the curve here. And here we got like this. Suppose this is B, OB is the line. In which case slope is more? Sloping, in which case it is more? Then you can see very clearly here the sloping is more. So in physics, mathematically we used to find it out the slope. So you can take 2 points like how I have taken here, or you can take, if it is a straight line, we can take only 1 point also. If you draw a perpendicular line, then you get here 90 degree. Let me mark it as MN. And here also I am taking 1 point. And then if I drop one perpendicular here, let me mark this as N dash N dash. Now let us see. Slope means angle to find out, that we call it as slope. Slope of line OB, slope of line OB is equal to tan theta. We do with tan theta. Tan theta is equal to perpendicular by base M dash N dash divided by O N dash. Let us take this as say 3 centimeter. If I take 3 centimeter, then this one will be around 1 centimeter. Then I will get the slope like this 3 here. In this case, slope of line OA, that will also be equal to tan theta. Tan theta is defined as perpendicular by base Mn divided by On. This case you can see Mn is shorter, say 1.5, and this one is big, say around 3.5 longer. So if you calculate it, 15 by 35, 5 3 are 15, 5 7 are 35, 0.74 are 28, 207 2 are 14, and so on. Like this you get the value. So this is just roughly I have taken to make you understand what is slope. Here you can see slope is more. Slope is more, as I said before, the inclination is more. This angle will be automatically more. By its value you will come to know. And if the slope is less, slope here is indicating theta. This is the angle. Here you will get the theta value as less. 0.42. This value will be lesser than this one. Here theta will be tan inverse of 3. This value is bigger and this value is smaller. So in physics, using this slope tan theta formula, we find out the inclination. How much the line is inclined. Now in same graph, if two lines are given to you like this, x-axis, y-axis, like this, like this, like this, if it is given, then by looking itself you can make out here the slope will be more, here it will be less, here it will be again lesser. Suppose say this is velocity, this is time. Velocity by time gives us what? Acceleration. So these are the graph for acceleration now. And if slope is more, that means here it is highly accelerated, the acceleration is more. Slope is less, this value angle is less, you will get it, then the acceleration will be less, and here again it will be lesser than that. This is the way you justify from the slope of the line. If you are taking here different physical quantities, then you will get different values. Here velocity by time gives us acceleration, so we are talking about acceleration. In general, if it is potential difference, this is current, then V by I gives us resistance, then this line will be for resistance. So by looking more slope, then the resistance will be more. Lesser the slope, the resistance will be less. And here is coming out acceleration, velocity versus time. Velocity by time gives us acceleration, so I am talking in terms of acceleration. Another technique is there to understand whose slope is more, like this you can do. Just if you draw one straight line like this parallel to x-axis, then also you can make out, because you are very familiar with geometry. By looking this, you see if I draw one just straight line and thus, then here the angle is less, here the angle is more, here it's even more than that. So automatically this slope is more, this slope is less, this slope is again lesser. So this way also you can justify in which case the slope will be more and in which case the slope will be less. And particularly that you have to keep in mind that in a velocity time graph, if I take the slope of the line, then I am going to get what? Acceleration, because velocity by time gives us acceleration. Suppose this is the question from the given figure. Here is your given figure. Find the average acceleration between points A and B. Between these 2 points A and B, you have to find out the average acceleration. Then what you'll have to do is, when you do the solution, from A you will drop down the perpendicular line towards x-axis, that is your time axis. From B also you will drop down the perpendicular line like this. Then from, you take one scale and pencil, and you can drop them like this. This one you can extend it this way. Then you have to find out the average acceleration. You mark this as C. Then BC by AC will give you the slope of this line AB. So what you'll do, you write down slope is equal to BC by AC. Then slope gives you the acceleration, you know, in the velocity time graph. So A is equal to, slope will give us the acceleration. BC, what is the value of BC? Then this value, 20 minus 10. It is 20 minus 10. This is in meter per second. This is for velocity. AC, the horizontal line will give you the time. 0 to 8 is 8 minus 4. This will give you 4. 8 minus 4. It will be in seconds. So change in velocity, change in time, we'll write down, and after that we'll calculate it. 10 meter per second divided by 4 second. So 4 2s are 8, 2 0, 4 5s are 20. Meter per second will become meter per second square. So like this you can find out the average acceleration. The SI unit of acceleration is meter per second square. The SI unit of acceleration is meter per second square. So the average acceleration also will be, the unit will be the same, meter per second square. Acceleration is a vector quantity, because here velocity is a vector quantity. So acceleration is also a vector quantity. It shows direction as well. It can be positive acceleration, it can be negative acceleration also. Answer can come out in negative as well. And the dimensional formula of acceleration, is, you already know how to find dimension. There is no mass, length and time. Length is on the top, 1, time is downside, so power will be minus 2. This way you write on the dimensional formula for acceleration. I hope it is clear. Now let us see a new term, that is your instantaneous acceleration. Instantaneous acceleration, by now you know instantaneous speed you have come across, instantaneous velocity you have come across. Here also the same thing, acceleration at any instant of time we call it as instantaneous acceleration. At any moment of time, acceleration we call it as instantaneous acceleration. And here also the way of writing is the same. Instantaneous acceleration AI, if you write, it is a limiting value as delta t tends to 0, change in velocity with respect to change in time, or in differential form if you write ddt of v. If you differentiate velocity, then you get acceleration. That is your instantaneous acceleration. So let us recap it, what we have learned in the beginning. Position, if you differentiate it, you get velocity, and velocity, if you differentiate it, you get acceleration. Like this you have to keep in mind. Now let us see one small question from here, and then we'll understand what is instantaneous acceleration, how to calculate it. Like this question, if you happen to get it, the velocity of a particle is given by v is equal to 2t square minus 3t plus 10. Then find the instantaneous acceleration at t equal to 5 seconds. This one we'll do at the end. First we'll find out the instantaneous acceleration. So we'll go for differentiation. Acceleration, instantaneous acceleration AI or AIN is equal to ddt of v. It will give you the instantaneous acceleration. This is ddt of v is 2t square minus 3t plus 10. Then we will write down in parts ddt of 2t square minus ddt of 3t plus ddt of 10. Then here 2 to the 4, you will apply the formula for differentiation. 2 to the 4, t 2 minus 1 will become 1 minus 3, here power is 1, 1 into 3 is 3, t to the power 1 minus 1 will become 0 plus differentiation of constant term is 0, there is no t to differentiate, so it will become 4t minus 3. Any number raised to the power 0 is 1, so it will become 3. Now at t equal to 5 seconds, instantaneous acceleration will become 4 into, this t value will put it here, 4 into t is 5 minus 3. So it will become 20 minus 3. 20 minus 3 is 17. Then you need to write down meter per second square. Here also you need to say meter per second square. Like this you can find out the instantaneous acceleration. So like that, if I give an example, suppose the position of an object is given by this formula x equal to 3t square minus 2t plus 5. You are asked to find out the velocity and you are asked to find out the acceleration. Suppose velocity to find out, you will differentiate position. This is position x or displacement. So if you do ddt of x, then what you will get is ddt of x, x is 3t square minus 2t plus 5. After learning how to do in parts like this, it's not necessary always that you have to write down like this. This way also you can do. Look here, 2 3s are 6. T 2 minus 1 is 1, so t minus 2. Here is 1. 1 into 2 is 2. T to the power 1 minus 1 is 0, so 1 exists. Then constant time is 0. So you get the velocity. This is your velocity. Now if you want to get acceleration, then you do ddt of v. Ddt of v, how will you do? Ddt of v is 60 minus 2. Then ddt of 60 will become 6. Then ddt of 2 will become 0. So it will be 6 units. If you write meter per second square, this is meter per second, and this is position, that is meter. Like this, in a nutshell, you can remember how to find out from position, how to find out velocity, from velocity, how to find out acceleration. So position, if you differentiate it, you will get velocity. Velocity, if you differentiate it, you will get acceleration. So if you cannot understand what is x, then you can write down position. X is position here, v is velocity, a is acceleration. This way you can remember overall what we have learned, calculus way of finding out velocity and acceleration from position. The next thing, now let us learn about uniform acceleration and non-uniform acceleration. Acceleration is said to be uniform if equal changes in velocity takes place in equal intervals of time. Mark my language. Here you have to know the definition of acceleration. Change in velocity with respect to time. So on the top it is change in velocity in a numerator. So if the body is in uniform acceleration, the change in velocity should be equal in equal intervals of time. Then that acceleration will be called as uniform acceleration. And non-uniform acceleration will be just the reverse of that. If unequal changes in velocity takes place in equal intervals of time, then the velocity will be called as non-uniform acceleration. Now after knowing this uniform acceleration and non-uniform acceleration, let us see some graphs related to velocity time graphs. Let us see about velocity time graph. A graph that relates between time and velocity, time along x-axis and velocity along y-axis, we call it as velocity time graph. The first one, let us see. If the body does not increase the velocity, does not decrease the velocity, if the velocity remains constant all throughout its motion, then we will draw a line, flat line parallel to the time axis. Neither the velocity increases nor it decreases, neither it goes up nor it comes down. It is going in the same with the same velocity, traveling with uniform velocity. And time does not wait for anyone, it will go on. Time will go on increasing when the body is traveling, so it will indicate a straight line here. This indicates the body is moving with constant velocity or zero acceleration. Zero acceleration. The velocity is remaining the same. Then it will look like this. Let us see the second one. When the body is moving with uniform acceleration, that means equal changes in velocity is taking place in equal intervals of time, then it will be an inclined straight line. This is your time axis, this is your velocity axis. So this will indicate like this. It is under uniform positive acceleration. The acceleration is increasing all the time, so it is positive. Also, the body is moving with uniform positive acceleration. Then it will indicate like this, inclined straight line. Then the third thing that we'll have to know is if the body is moving with negative acceleration, then the graph will be of this form. This time axis, velocity axis, the velocity time graph we are discussing about. Negative acceleration, then acceleration will come down, the curve will come down. This indicates the body is decreasing the velocity. Time is as I said before, so it goes on increasing. The velocity is decreasing, it's coming down, so it will indicate negative acceleration. But when we discuss about, this is all about your uniformly accelerated motion. When we talk about non-uniform acceleration, then in that case the curve, velocity time curve or velocity time graph will be a curved line. This indicates non-uniform acceleration. Non-uniform acceleration. In this case, if you draw lines like this, you will understand here the angle is less, here the angle is more, and here is again lesser. The angle keeps on changing, the slope line and the slope keeps on changing. That's why it is in non-uniform acceleration. If it is moving with uniform acceleration, if it is like this, if you draw lines this way, this angle remains the same, the slope remains the same. That will indicate this uniform acceleration. Let us solve this question. Here you learn one new thing. In velocity time graph, like this, I write down here, the area under velocity time graph gives us displacement. That you have to know. In any velocity time graph that you have, suppose if this is your velocity time graph, like this, suppose parallel, then this area under this line, this area under this velocity time graph will give us displacement. This one to know, I have selected one question, you can see on the board. Here one velocity time graph is given to you. This is your graph. This x-axis represents time axis in seconds, 1, 2, 3, 4, 5, 6, 7 and so on. And y-axis positive velocity 10, 20, 30 up above, and below negative y-axis negative velocity is minus 10, minus 20, minus 30 and so on downside. And this is a curve, suppose ABC is given to you. From here you have to find out the displacement in the first 3 seconds. Then to find out the displacement in the first 3 seconds, this is first 1 second, 2 second, 3 second. This area of triangle AOB will give you the displacement in the first 3 seconds. That's what is written here. The area under velocity time graph gives us displacement that you need to know. So solution when you do displacement in the first 3 seconds, displacement we write it as S, will be area under velocity time graph. Now to find out the area, you can see very clearly it is a triangle AOB. So you have to find area of triangle AOB, and as it is a right angle triangle, you can see here it is 90 degree. We will use the formula half into base into height. Half into base, that is OB, and height is OA. Since area of triangle is equal to half into base into height, from mensuration you know. Put the values. Half of OB is how much? OB, 3 seconds. I am writing here 3 in place of OB. And OA, that is your velocity, that is from 0 to 30, it is 30 meter per second. So if you use the unit, displacement unit, you know SI unit is meter. This second will get cancelled. 2 15 times is 30. So 15 3s are 45 meter. Like this you will get the displacement. This is for the first one. Now for the second one, acceleration for the above graph. Now regarding this, we have already discussed. Slope of velocity time graph will give us acceleration. Now how to find out the slope here? You don't have to select any 2 points to make a right triangle. Here you can see already right triangle is existing. Slope of the line you can find out here. Theta, this will give you the slope. So second one to do, I'm doing here. Acceleration, we'll write it as A is equal to slope of VT graph. And how to find out slope, you know already. Perpendicular by base tan theta. perpendicular by base. Here tan theta perpendicular is AO divided by base is OB. But here you have to be very careful. The graph is coming down. So AO is indicating the displacement. Displacement here is from 30. This final position is 0 here. 0. And initial velocity is 30. So it will be 0 minus 30. It will be 0 minus 30. Change in velocity. It will be negative as it is coming down. Coming down, and OB is the time factor. OB is here still 3, so it is minus 30 divided by 3 will give you minus 10 meter per second square. If the graph goes up, then it's positive acceleration. You will take it 30 minus 0. So it's coming down. So final velocity is 0. Initial velocity is 30. Final is 0. Initial is 30. So I'm taking 0 minus 30 here. So likewise, you can find out the acceleration, and you have to have presence of mind whether it's negative acceleration or positive acceleration. Depending upon that, you have to select it. So these are the two things you have to know. Slope gives us acceleration, area gives us displacement in a velocity time graph. With this, we'll come to an end of this video. Stay tuned with LFI Educates. Thank you.